So like Ms. Jackson said, we're reviewing domain and range today. If this is the time domain and range clicks for you, that's great. We've done domain and range for linear equations. We've done domain and range for exponential equations. And now we're going to talk about domain and range, which is the same thing, hasn't changed, but for quadratic functions. So let's go over this vocabulary again. The set of all input values or x values is called the what? The domain is the x values. When I'm looking at the graph, that means I'm reading the graph like I read a book from the left to the right. I'm looking at the x-axis for the x values and for the inputs. What's the set of all y values called? Range. Now, one of the ways I've noticed that some people, like one of my students told me this, that they're remembering the difference between domain and range, is if you like accidentally make the g into a y, like, okay, well, range is y. Do you see how I did that? Let me do it again. Okay, so this used to be a g in range, but if you just like don't write it correctly, it looks like a y, right? Range is the y's. Okay. When we're doing the range, we're reading the graph from the bottom to the top. This is just least to greatest for both domain and range. Just happens to be that the least going up and down is at the bottom, which makes sense because it's lower and then higher. So left and right, bottom and top. We've had a few acronyms that we've used throughout the year to talk about this. We have Dolor the robot, domain being from the left to the right, and range being from the bottom to the top. That's the DLR in Dolor and the RBT in robot. We've also talked about how domain is the x's and range is the y with Dr. XY. Anytime you're asked a question about domain and range, especially when I'm asking you to show your work, / when you're taking a test by yourself to help you know you got the right answer, I should see DRXY written down and the correct letter circled so that you know what letter you're looking for. So if we look at this first example, this is a parabola. We learned about all the parts of this parabola last class. And on your homework, it actually asked you about the domain and range. I wanted to see if you remembered. The domain of any parabola is all real numbers as long as there's no ending points for this graph. Now, why is that the case? Does anyone know why? Yeah, those arrows are pointing off in both directions, which means there's never a stopping point for this graph. So if I fill in what the domain is on the domain axis, on the x-axis, it's going to look something like this with arrows on both sides. I've used every single number on the domain. The whole number line is colored in. That's all real numbers. I want you to go ahead and color it in like that. I know you only have pencil, but go ahead and show me on the number line where it's shown in, because this is going to look different when we do range, so it won't just be like colored in for no reason. The range for this graph is everything that's bigger than or equal to -3. Why in the world is -3 such an important number? Look at this graph. Why would -3 for the y's?
It's at the bottom.
It's at the bottom. It's the lowest that this graph goes. And if I color in the y-axis where the whole graph shows up, it starts at that value down there at -3, and goes all the way upwards. So we'd say that all of the y values are above -3. That's greater than or equal to. Greater than is above. Why is it equal to? Why is that line underneath there?
Because it's negative. It's a -3.
No, because it's a -3. When do I not write the line underneath there?
When you want it exactly. When it's filled in, right? When the dot's filled in?
Opposite.
When the dot's open.
When the dot's open, if you don't actually see an open dot down there, you assume that it's a closed dot. So they're very obvious when it's open, otherwise it's closed. Okay? If we look at this next graph, just for another example here, again, the domain is all real numbers. If I were to color in that number line, because of the arrows at each side of this graph, it's going to keep going for the entire number line. The entire x number line is used, so it's all real numbers. But the range is different. What's the highest point for this parabola? 4. And then the whole parabola extends downwards, correct? Yeah, that's its highest point. The rest of it is below it. So we use the symbol that means below, less than or equal to. Now, this thing about this is we're not only just going to be talking about domain and range in inequalities that look like a math sentence. we're also going to be talking about them in English sentences. Okay? So we're going to translate these math sentences into English sentences, but I gave you sentence stems on the back, so you just have to fill in my numbers. Because the way that you say them can be written out loud. Written out loud? Written, how would you say that? Written out. Yeah, okay. I was out of struggle. Okay, let's look at this first example here. We're going to write the domain and range in both inequalities like we just did, and then out loud in words. Why do I keep saying out loud? You know what I mean. So let's first start by looking at my parabola. Does this parabola have endpoints on the left and right? No, it has arrows. So I'm going to color in my entire x-axis because that's the entirety of the number line that I can use. The inequality that I would use to describe this would be all real numbers. Does anyone remember the symbol for all real numbers? It's an R with an extra line through it. Very good. That's all real numbers. So in words, we just write all real numbers. Right. We had found the domain and range. Well, sorry. We had found the domain. We said it was the entire number line. That's where it shows up because of the arrows, all real numbers. And then I forgot who it was, but said something about the bottom of the graph is going to be important. Why is the bottom of this graph important? That's the lowest that it goes. How low does it go? Don't say 4. -2. Okay, don't say 4 because that's the wideness. It's the direction it's going side to side. We're looking for the lowest, which is down at -2. Now, if I'm shading in this number line for where this graph shows up, would I start shading downwards? No. Why not? Does the graph show up down there? That parabola is not there. We talk about the domain and range where the graph actually shows up. So we're going to shade in. We're going to color in our number line going upwards because that's where the parabola is. So would we say that the whole parabola is above or below -2? Above, because that's as low as it goes. So all we have to do is use the math sentence that says the whole graph is above -2. This symbol is called greater than or equal to. You have to start remembering these symbols. It looks like your right hand, it means bigger than, or on the right side of. In this case, since we're doing bottoms and tops, it's bigger than. Okay? If we translate that into words, we're actually going to use the phrase that this is all real numbers, and then we choose either greater or less than or equal to, and then the number. So greater than, because that's the symbol we use. Very good. So all real numbers greater than or equal to -2. It's a little wordy, which is why I gave you the sentence stem there, because I want you to be able to translate this math sentence into an English math sentence. So we're taking the inequality and writing it out in words. Okay, let's do the second one. We're going to stick with doing most of these together just because I want to make sure I clear up any inconsistencies in your thinking. So if we look at the first one, again, we're wanting domain. Domain is to the left and the right, but if you look at the x-axis, whoa, I didn't mean to do that. Boop. If you look at the x-axis on the left and the right, does that graph ever stop? No, it is so tempting to try to say that it shows up between 2 and 0, or sorry, -2 and 0. That's wrong. It keeps going. It's very tempting to say it stops at -3 and at 1. Very tempting, but we know that those arrows in the way a parabola is shaped is that it's going to keep going if we zoomed out. So our inequality that we would use, again, for domain is all real numbers, and that's how we say it in words, all real numbers. In Algebra 2, you're actually going to learn a different notation for that, just as a little preview in case you're wondering. It's called interval notation, and you would say from -infinity to infinity, which I think is a really interesting way to talk about all real numbers. We're saying start at -infinity. Turn your paper sideways and draw an 8, and then turn it back, like flip it 90 degrees, draw an 8, and then flip it back, and it kind of looks like an infinity. Oh. Or you can put 2 circles next to each other. Or you just get really good at doing the infinity sign. Okay, we're going to also do the range. Now the range, again, because it's a parabola, I know it's not going to be all real numbers because it either has a highest or a lowest point. Does this have a highest or a lowest point? Lowest. For real? It has a highest point. Does anyone remember that vocabulary? It starts with an M that we used for that. Maximum. This is our maximum value. Very good. How high does this graph go? 2. And if I were to color in my number line to kind of show that, we'd say, okay, starts at 2 and goes this direction That's where the parabola shows up. I did not draw in my domain. Sorry, I meant to do that. So if we write the inequality for the range, we need a sentence, a math sentence that says the whole thing shows up below or at 2. So the whole thing shows up below or exactly equal to 2. This symbol flips around. That's now the less than or equal to symbol, which means below. Because the whole parabola, the number line that I'm shading in is below the number 2. So if we translate that to words, it's going to be all real numbers. What? Less than or equal to? 2. Yeah, well, all we're doing is translating that math inequality sentence into just English words. Now this next example is kind of interesting. It changes a little bit. Is there arrows at the end of this graph anymore?
No.
No, so we're actually going to have ending points for both domain and range. This parabola actually models probably some sort of projectile motion, some sort of, I don't know, somebody kicked a soccer ball and boom, goes up in the air and then lands back down on the ground. So we have a starting and a stopping point in my domain for the flight of the ball or golf ball or something that flies up in the air and then comes back down. So let's talk about the domain. We want to look from the left to the right. On the left, what's the beginning value? Where does this graph begin on the x-axis? 0, 0, which is the x value of 0. And if I color in this number line, where does it stop? At 5, 0. So it stops at the x value of 5. So my inequality to describe this domain is from 0 with a closed circle all the way to 5. I have my starting and my stopping points. It has 2 sides because there's 2 ending points. If we translate that into words, it's going to be all real numbers. And this is where it gets weird. You only have less than symbols in your actual inequality here because we're going from least to greatest. But when we write this out in words, trust me when I say it's all real numbers greater than or equal to 0 and less than or equal to 5. Now that's
a lot of words.
What? What's not a word?
I said that's a lot of words.
Oh, it's a lot of words, yeah. So here's what's weird. My inequality only has less than signs, but my math sentence had one greater than sign. Why is that the case?
Because of 5?
Well, what about the 5?
This is because of the circle.
Is it because of the circle?
Circle on the back side of it?
What you mean? This?
No, the number.
This?
No.
I'm so lost. Oh, on top?
Yes, no. The problem, the answer.
I'm so confused.
Me too.
The
Okay.
circle is behind the greater, the less greater.
Y'all know that's a 0.
Oh, I was 0.
I was like, there's no circles. That's the number 0. It does have to do with this circle, though, this number 0. This does have to do with 0. If you notice, 0 is right here. All of the numbers that are in this number line, are they bigger or less than 0? Bigger, which is why we end up saying greater than or equal to 0, but they're all smaller than 5, so less than or equal to 5. The sentences are weird. That's why I gave you sentence stems. Let's look at the range. Can someone tell me how low this graph goes?
0.
It begins at 0 because, again, if it went further than 0, we'd be like underground, which is fine, I guess, but
No, it's not fine.
it's not fine. Okay, fine. And then if we go up, what's the highest it gets to? 100. So my number line for the range goes from a bottom value of 0 to a top value of 100. Oh, that's the weirdest 100 I've ever written.
I went to hundreds like that.
I was running out of room, TBH. So if I look again, I'm using just less than or equal to symbols because that's how we set up domain and range for a two-sided inequality. But if I change this into words,
0 greater than 5.
it's going to be greater than 0,
Greater than 100.
not also greater than 100, because does it go bigger than 100? It's going to be less than or equal to 100. Again, that's a weird way to talk about inequalities is in like math sentence words. What? English sentences and words. But we can totally just translate those inequalities. Match up the numbers for the most part. They're not really going to be tricky answer choices like that. Cool, 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 great. When you've got this down, flip it over. And what do you notice about the problems on the backside? What?
We don't see the line.
We don't see the line. But guess what we do see? A whole equation. And what do you have that can visualize equations for you? Great. I need everybody to type that equation into Desmos, and I want you to zoom to a place where you can see the whole thing or see most of the shape. I'll give you a second to type that in. Make sure you're in test mode. Yes, you can type the g of x, by the way. I feel like someone's going to ask me that. That g of x is fine to be a letter you type in. It's just the name of the function, like f of x. Now you have yours on your screen, and I want you to sketch it onto your paper. And by sketch, I mean you don't have to make it accurate because like yours goes up all the way to like what, number 37 and over to like 12. Just make it the right shape in the right quadrant. So this one is mostly in quadrant 1, so I'm going to do something like this. Ooh, yikes. Good enough. I'm going to put arrows at the end because I know it keeps extending. And I'm going to put a little dot at the very top and label my vertex. Desmos will show you that important value of the vertex if you click on it. So what is the value of that vertex? 12, 37. Okay, great. That's going to be important for us because we need to know the highest or the lowest point. So I always look for the vertex. I can find other important points for this parabola, but in regards to domain and range, we really just need that vertex for this problem. Okay. The domain, if we look to the left and the right, does this graph ever stop? No, so what do we say for the domain? All real numbers again. Very good. That's going to be a...
Because sometimes it's not going to be given to you, but you know how to sketch it yourself.
That should be. What if you get the numbers wrong?
Well,
You
that's
mean-
why you have to transcribe things correctly. It's very important.
Like you typed it in wrong? Just type it in right.
Usually you'll be able to like copy and paste, but sometimes it's a PDF, so you have to be able to type it.
So my next question is, if I'm asking you for the range, which I am, you look for one of the maximum or minimum values. Does this have a max or a min? A max. It has a highest point. That means big, tallest. And what is that tallest value? 37. So I'm just going to plot the point 37 on my number line and pretend like I'm using a good scale. And I'm going to shade in where the graph goes on my number line so that I can tell you the range. That range, that number line that I've highlighted is everything that's below the number 37. So we would write that the range is everything below 37. Using less than or equal to say that it's below because that's less than, it's lower. Below. Looks like my left hand. So if we translate that to words, it's all real numbers. Is it greater or less than?
Greater.
Oh, my gosh. Does it look like our left hand or our right hand, folks?
Yes.
Okay, left hand is less than.
Talking about the sign.
Yes. Less than or equal to 37. Okay, so I've seen really good work. We started by typing in the f of x function because they gave us an equation that we can visualize. That's the number one thing I can tell you to help yourself out. We are better visual learners,
It's 0.6.
so we need to be able to see what equation they've given me. My graph is going to look something like this. Is this kind of what your sketch looks like? As long as you labeled that vertex, which is at 0, 16, you should be good. The inequality that represents my domain is from negative infinity to infinity, which means this is using all real numbers. Huh?
What if you actually get a number right there?
We will do some examples where you might. So if it has ending points, you'll have actual numbers, but this has arrows, or it goes off screen for you. But I guess I could put it in words. All real numbers. And then if we do the range, we're looking for where the graph has either a maximum or a minimum. Does this graph have a max or a min?
Max.
Maximum, which means it has a highest point at 16, and everything else occurs below it. The whole function shows up below it, so we should use the less than or equal to symbol to describe less than 16. All real numbers less than or equal to 16. I have a quick question for you. just as a little review from what we did last time. What kind of parabolas are these? Are these happy or sad? Sad parabolas. Okay, maybe I could tell you how to tell from the function, from the equation, why it's a sad parabola. Can everybody maybe figure it out? They are going down, but I can look just at that equation.
They got negatives in it?
Oh, great. So if we look at this one, is this one going to be a happy or sad parabola?
Sad.
Wait, why is it sad?
Because it's got the negative right there.
Okay, so here's the important thing. That negative affects the x squared. Right here in front of the thing that is squared, you see how you have the negative sign in front of the thing that's squared?
Yes.
And right here you see how I have a negative sign in front of the thing that's squared? That's what makes it a sad parabola. So is this one got a negative in front of the thing that's squared?
Oh, no.
No, so is this going to be a happy or a sad parabola?
Happy.
Okay, great. Let's do the same thing for this happy parabola. When we graph it, what does it look like? You probably have to type it in. I'm not going to graph it for you. You can graph it. All right, so hopefully your sketch looks something like this. I think it's in quadrant 3, right? Is that where the like turning point is? Down here? Let me put my arrows up there. And that vertex is at -1, -4. Is that correct? Did I use the right vertex? I honestly don't remember, and I didn't graph it. Okay, thank you. So if we look at the domain, we've got arrows on both sides, so this graph's going to keep going. So I would answer that the domain is all real numbers. Should start kind of seeing that this is going to be your answer a lot for domain for these guys. Same with exponential. It's probably the answer because unless it has ending points. But when we look at the range, does this one have a highest or a lowest point?
Lowest.
It has a lowest point. That lowest point is -4. And the whole graph, the whole parabola is above that. I guess I could have graphed that a little bit more accurately. So we would say that y is above -4. So we shift that symbol to say above because the whole parabola, the number line that I'm using, is above that -4. Cool, great, awesome. When you've got this written down, I want you to flip your paper over again because we've got another representation of domain and range that we need to talk about today. That representation is tables. We can also talk about domain and range for these functions in tables. Now, when you see a table, your brain should probably think, I should write an equation for that. And you'd want to...
Oh, my God.
Okay, after it says, oh my gosh, then you should think, I'll probably make a table of this in Desmos and plot these points. That's a really great idea, and you're actually going to do that next class. But today, we're just talking about the domain and the range. Remind me one more time. The domain is which letter? The what? The X. And oh yeah, not like D for domain, but the range is what variable? The Y, the output, the G of X. So with this table, we have some ordered pairs. We're going to be able to talk about the domain and the range. So the domain, we look at the numbers. For this problem, which is going to have some context, it's not typed on here, but it has some context in this problem. All real numbers, where does this number begin at? What's the smallest number on the X values?
-4.
You see how this is the smallest number? We're going to have to say everything's bigger than that smallest number. And what's the largest number there?
8.
So we're going to say everything is less than that largest number. We're just looking for the biggest and the smallest, the least and the greatest number to talk about the domain. When we talk about the range, though, you can't just look at the beginning and the end of this graph. You actually have to look at the numbers. Can anyone notice something about some of the numbers on that table for the G of X row? So we noticed at this table that the 2's are repeating, the -22's are repeating, and they're centered around this value right here. This right here, that's your vertex. This coordinate point right here, 4, -30, that's your vertex. Which means, does this graph have a maximum or a minimum? How do you know minimum?
Because it got that negative. That is 30.
Oh, it's not necessarily because it's negative, but look at the numbers. We go from 98 to 42 to 2 to 22 to -30, back up to -22. This is going to be a happy parabola. The numbers are getting smaller and then getting bigger again, centered around that value of -30. So we would say that the range, is it going to be greater than or less than -30?
Greater than.
Greater than, it's above negative 30. That's where we'd color in on our number line.
Mine got more than that.
It does. What else does it say on there?
It's greater than or size less to than equal to.
Okay, so let's look. So less than, oh sorry, greater, I forgot mine doesn't type all that y'all says on your paper in my handwriting. Okay, we always usually answered another number. What's the largest that this goes up to?
2.
Was that the largest it goes up to? 98 is the biggest it goes up to, and everything else is below that.
So it's less.
So it's less than 98. Let's do this again for the next table, because this is kind of confusing because you have to look at the table to try to figure out the kind of parabola you have. The table shows the height in feet of a golf ball hit in the air where t is the number of seconds elapsed since the ball was hit. So again, we're like kicking a soccer ball, we're hitting a golf ball, we're throwing something from the ground. At what time do we start counting? What's the first x value?
0.
0. So we're going to say everything is greater than 0
Less than 12.
and less than 12. Very good, because that's my beginning and ending. That's when the ball got kicked or putted. What do you do? Golf ball got hit, and that's when it hit the ground. Took 12 seconds for it to go up and come back down. Can you guys find the vertex?
Yes.
What is it?
6,112.9.
What?
112.9.
Why is it 112.9, Yannick?
That's what I said.
Oh, 6 comma. I was like, where did you get the 6 from? 6 comma. Yeah. This is my vertex. Is that what you were saying? And why do we know that that's my vertex?
Because between 109.8.
Yeah, it's centered between some repeating numbers. Absolutely perfect. Now, is this a happy or a sad parabola?
Happy.
Sad.
Ooh, I hear both. Think about it. We just kicked a golf ball. What do you do with golf balls?
Sad.
You hit a golf ball. Does the golf ball go down?
Yes.
No, go up.
It goes up and then it comes back down, right? This is a sad parabola.
I said that.
I know I heard. Okay, so we're saying that the range, what's the lowest it goes?
0.
0. So it has to be bigger than 0. That's the ground. It can't go underground. I mean, I guess it could, but like, no. We're not that good at golf. Or bad at golf, depending on how you think about it. And then, what is golf? It's that sport with the putters and they like, you know what I'm talking about? And then we have everything greater than 0. And what's the highest it goes to again?
112.9.
112.9. Yeah, that's how high it goes. That's the y value. So that's the range of this golf ball. It goes from the ground up to its highest point, vertex, and then back down again. Tables are hard. I will give that to you. They are the most difficult version, trying to determine domain and range just because we don't have a visual. But next class, you will figure out how to create a visual from these tables to answer the questions. Uh-huh. Last thing. Now we're going to do domain and range one last time. Back at graphs. Everybody likes the graphs. But we're going to have some ending points. Let's look at the couple examples they gave us here and color in our number lines like we'd been doing. So if we look for the domain is left to right. Well, I see that I have this ending open, specifically open, ending point at -2. And then it just keeps going to the left. So my domain is all of the x values that is just greater than -2. Why did I not put the line here again underneath that? Because it's open. Fabulous. Okay, now we need to go from the bottom to the top. Important question, and think about this before you ask. Is this the bottom of the graph?
No.
Where?
Right here.
No.
No. Don't get confused and go to an endpoint. Actually go to the bottom. What's the lowest this graph goes? -3. And then it keeps extending this way, and I'm going to follow that arrow up at the top. So my range is everything bigger than, greater than, or equal to -3. Let's color in the number line for the next example. Domain, again, we're looking left to right. Well, I have this open circle at 0, and then the graph extending with an arrow to the right. So again, I say x is less than 0. Whoa, that's a whole typo. Isn't it?
Yes.
Let's fix that. Get rid of that symbol. It should be greater than 0. Good catch on my typo. And then the range, we start up at the top, which is 4 with an open circle. And then we shade in where that graph shows up, which is below. So we know that we should have y is less than 4 with an open circle again because that open circle. So no line underneath. Now last but not least, a two-sided inequality is going to be used for this next one. Why does this last problem have a two-sided inequality when the rest of them only had a one-sided? What's different about this one?
There's 2 points.
There's 2 actual ending points. Do y'all see any arrows?
No.
No arrows means that we're going to have 2 sides. So if we, again, color in our number line for this one, the way we've been doing. For the domain, we say start here and then continue on until the next ending point, which is right here, between 0 and 5. That's it. There's no arrow going off in one of the directions. For the range, we have the bottom. And all of that is included until we get to the top for those values. So we have -5 less than or equal to y less than or equal to 4. Just to make sure we understand these, and because this is a review, like I've taught you this before, you have 2 examples down there that I want you to try on your own. I'm only going to give you like a minute or 2 to work on it, and then we'll go over it, but just try to see if you can prove to yourself you know how to do these problems. So you're doing both examples down here. Okay, seeing some really good stuff. Like I said, I wasn't going to give you a ton of time on this, which means I probably cut off your thinking. But if I zoom in on this first one and I talk about its domain, I'm looking from the left to the right. My number line starts at what number?
-4.
-4 and goes all the way to what number?
1.
1. So I have the inequality -4 with a closed circle and then 1 with an open circle. That's where the graph shows up side to side. That's its width almost. Is this the bottom of the graph?
No.
Is this how low the graph goes?
No.
No, we need to go to the actual bottom of the graph, which is at what number?
-7.
And then it goes all the way up to
2.
2.
3.
What?
Just -3.
It keeps going though. Doesn't it go all the way up to 2?
Oh.
So we'd say that the range, the place where the graph shows up, is from 7 with a closed circle to 2 with an open circle. That's the height of the graph, from and to, the lowest and the highest point. Okay, y'all are going to help me with this one because I know I cut you off probably before you got to this one. But if we're doing domain, we need to look to the left and the right. Malik, where does this graph start on the left? What x value? -2. Okay, cool. So I'm going to circle that one, and it's open, so I'm going to make sure my circle is also open. And then, Malik, if I start coloring in on this number line, am I going to stop somewhere?
Yeah.
Where am I stopping? At the dot. What value is that? 7. So my domain is from -2 with an open circle to 7 with a closed circle. That's where on the number line it shows up. And then Delaney, if I want to go from the bottom of this graph to the top, where's the bottom? -8. So I'm going to draw on my number line at -8. And I'm going to go upwards and keep going upwards until I get to what number, Delaney? Are you right there where I stopped coloring? At 0, yeah. It goes to 0. So I can say that the range goes from -8 to 0. Whoa, what? I just wrote an 8 again. To 0. My bad. Just erase half of it and then it's a 0.